We've looked at pressure, now let's look at temperature. We like to say temperature is basically a measure of how fast the particles are moving. Actually, kinetic energy involves the mass as well, and that'll be important a little bit later. But it does depend on V as the velocity. So the faster they're moving, the higher the temperature. We need to know how to get to Kelvin. Kelvin is the temperature scale that is used in the gas law calculations. So you'll be calculating, or you'll be converting to Kelvin a lot. So know this number. This has been rounded off, so this has 5 sig figs, 2 past the decimal for your sig figs. Kelvin is based on absolute zero. In other words, absolute zero is the coldest possible temperature, and that is 0 Kelvin. Since temperature is a measure of motion, as you cool something down, the particles move slower and slower. If they get cold enough, they stop. That's at 0 Kelvin. You can't get any colder than that. Notice in this definition, we say the average kinetic energy of particles. That implies that all of the particles in anything but in a gas are not moving at the same speed, same velocity. Let's see why that's true, why there's actually a distribution of kinetic energies at any given temperature. Let's start with just one particle in there and watch how it bounces around. It's going to keep the same speed the whole time. The collisions with the container wall are elastic. Okay. So they're not changing with time. Let's see what happens when we put more in. Now notice when I first put these in, everything will have the same speed, but that will change, and see if you can tell why that changes. So I'm going to put them in, all the same speed. Seems like they're all still the same. Oh, now some things are changing. Now some are going faster and some are going slower. You can definitely find slower ones and faster ones now. What caused that change? It's basically the collisions. Depending on how they collide, sometimes one slows down and the other speeds up. If I put a lot in here, let them randomize, you definitely can see some that are moving very fast and some that are moving very slow. So that's what we mean by a distribution of energies.